Hello students, in this video we will see about one more type of loader. We call it as Bootstrap loader. So let us see what is this Bootstrap loader. As soon as you put on your system, maybe your laptop or your desktop, you might be seeing that there is one program known as Bootstrap loader. Okay, and sometimes if at all it is not loaded properly, it will ask to press F1 key. I think you must have you must remember that. So what is this Bootstrap loader? Let us see. So as soon as you put on the power, then the Bootstrap loader will be loaded from ROM to memory. Okay, so this Bootstrap loader loads the loader from the hard disk or whatever disk, and then loader loads the operating system from the disk, and it transfers the control from loader to operating system. So basically Bootstrap loader is a main and primary and the first program which will be loaded onto the memory as soon as you put on the system. So this Bootstrap loader, initially it will be at the memory location 0, and then whenever it starts with the operating system, okay, by pressing F1 device, so it will after loading the operating system, the control is transferred to the instruction at the address 80. This is hexadecimal 0x80. This is a standard location, okay, memory location for the operating system. So when the computer is first turned on or restarted, a special type of absolute loader, we call it as Bootstrap loader, is executed, and this loads the operating system onto the system, that is to the memory. Okay, and the Bootstrap loader is written into ROM at the address 0x0000 by the manufacturers. And the Bootstrap loader loads the operating system residing in the hard disk into the main memory, starting at the fixed address 0080. So this is always 0080 hexadecimal. And the Bootstrap loader executes a jump to address 80, and then the OS will start executing it. And once the OS is fully loaded, the user can start giving the commands, to utilize all the sources of the resources of the system. Okay, so let us see one example of we have one operating system which is to be loaded, and these are some of the object codes. Okay, so 17202D48 and whatever. Okay, some memory address, some hexadecimal memory addresses we have here, and then each hexadecimal digit here occupies 1 byte of memory space. That means digit 1 takes 1 byte of memory space. Similarly, 7 takes 1 byte of memory space. But in fact, whenever we saw this any loader, okay, for that matter abstract loader also, each digit must occupy only half byte. Okay, so each digit must occupy only half byte, whereas now each digit is occupying 1 byte of memory space. So what we need to do is we need to convert each digit taking 1 byte of memory space into half byte. Okay, so that is what we are going to do now. So we have a program for Bootstrap loader for SICXC machine. So the name of the program is boot here. It is starting at the address 0 for any SICXC program. And this Bootstrap reads the object code from device F1 and then enters it into the memory starting at address hexadecimal 80. Okay. And then after all the code from device F1 has been seen, entered into memory, the Bootstrap executes a jump to address 80 to begin execution of the program just loaded. And the register X contains the next address to be loaded. So these are some of the comments they have given, and let us see the program. So initially the register A will be cleared to 0, and then register X will be initialized with the value 128. Okay, LDX hash 128. 128 is a decimal number. Okay, when you convert it to hexadecimal, that is 80. And you know what is 80 here? Okay, so this is a memory address starting at the Bootstrap reads that address at 80. So we need to initialize the register X with hexadecimal 80. And then we are jumping to the subroutine called getC. So let us see what is there in getC, and then whatever values which are returned, that will be again it will be stored, and then the values will be stored again in another register called S here. So now changed value is there in accumulator. Again, that will be saved in the second register, that is S here. So once it is stored in register S, now we are doing shift L operator. That means shift 4 bits. Okay, S comma 4 means shift the value, the contents of the S register to the left by how many bits? 4 bits here. Okay, so we are shifting 4 bits from the register S to the left. And then look at this, we are again calling the subroutine getC here. That means, see, suppose we have, let us say 17202D48, and I wanted to take 1, I have to convert it into half byte, then again 7, I have to convert it into again half byte. So I need to make 1, 7, both I need to read one after other, and then I need to make 17 as 1 byte totally. So that is why getC subroutine is called twice. I think it is clear now. So getC first time 1 for digit 1 it will be called, and second time getC for digit 7 it will be called. So whatever is there in getC, let us see in subroutine, and then the same way it will be stored, and then we will see the after getting both the digits here, both the binary values, we will combine those digits to form 1 byte, and then store the address in register X. So once the register X is stored with that, then we will increment X by 1 here. Okay, and this procedure continues till all the numbers are over. All the digits are read. So now this is a subroutine called getC. So subroutine to read one character from input device and then convert it from ASCII code to hexadecimal digit value. And the converted digit value is returned in register A. And when end of file is read, control is transferred to the starting address, that is hexadecimal 80. Okay, so let us see this one. getC is a program name here. So we are checking, okay, we are taking the input from the input device, and then we are looping it until the system is ready, and then we will input the character here. So if the character is hexadecimal 4, if the character is 4, which is decimal, which is also hexadecimal 4. Okay, so hexadecimal 4, then that means it is the end of the file. Okay, and then you need to jump to the value that is 80 here. Okay, so jump to start of the program. Otherwise what we have to do is you need to compare to 48 decimal, which is nothing but 13 hexadecimal. That means you know what is the ASCII character of 0 in decimal. So 0 is nothing but ASCII value 48. So we will compare the memory location, that is each digit, with 48, that is hexadecimal 30. Okay, that means let's take this one. Let us say I have 17 here. So 1 is a hexadecimal number that will be converted to hexadecimal, that will be converted to ASCII here, and then compared with it is compared with hexadecimal 30. Okay, and then after this, again let us see, if at all JLT means jump to the loop if it is less than 0. So if at all the value is less than 0, and then you need to just skip it out, because we don't take any negative value. Otherwise what we are doing is we will subtract hexadecimal 30 from the ASCII code, and then if the result is less than 10, then the conversion is complete. Otherwise we will have to consider even the characters A to F, because it is hexadecimal. So we will again subtract 7 from that. Okay, how it is possible? Let us take one example. So we are subtracting 7 also from that for the hexadecimal digits A to F, and then we will return the values to the caller, and then again XF1 here. That means it is a code for input device, and this process continues till all the digits are read. Okay, so this is the algorithm, the same program, it is just made as an algorithm here. So X will be initially 80, and then within a loop we have first get the character and convert it from the ASCII character to the value of hexadecimal digit, and then save it in S here. Then whatever value I get, we will save it in a high order 4 bits. That means shift left here we are doing. Again we will call the subroutine getC, and again we will, whatever value we get, we will combine with A now. That is A plus A, we will combine with S now, and then we will store it in the register. Then X will be incremented by 1. And the subroutine getC, we will read one character from the accumulator. Then if at all A is 04, that is the end of file, then it will jump to the location 0x80. That is the starting address of the operating system, that is Bootstrap loader here. And then if at all A is less than 40, then again go fetch one more character because it is less than 0. And otherwise you have to subtract from 30, that is hexadecimal 30, and then the value will be returned. And if A is less than 10, then again we need to subtract for from 7, because we need to return the character A to F here. Okay, so let us see this with one example. So I have taken one example. Let us say the object code is 17202D. Okay, 17202D. So I have written the object code 17202D. See, it's 3 bytes, supposed to be 3 bytes. Okay, because here it is taking, this is half byte, each one is supposed to be half byte, so I have to have only 3 bytes stored. But in fact, whenever we just take it as without any algorithm, it will be occupying, each one will be occupying 1 byte. So totally 6 bytes it will be occupying. That we need to change it to 3 bytes. Okay, so that is a procedure we have to follow. So let us take 172020, and then its ASCII value in hexadecimal, let us see. So the one in object code, that is hexadecimal 1, we need to convert it into ASCII character. Okay, so we know what is 1 in ASCII. What is our each one is a character, guys, you should be knowing. Okay, 1 is a character, within single quotes you should be writing. Similarly 7 is a character, so each one is a character here. So what is a character 1 equivalent ASCII is nothing but 49 in decimal. When you convert it into hexadecimal, it will be 31. Okay, so 1 character, when you convert it into ASCII hexadecimal, it will be 31. So that is what we have done here. So we have seen initialize the register to hexadecimal 80, and then we have to move on to the subroutine getC. So we have moved to subroutine getC here, and then compare with 4. Do we have any hexadecimal 4 here? No, that means it is it is not the end of the file. So 80 now you need to compare it with 48, that is hexadecimal 30. So we will compare it and then we will subtract it. So 1 is converted to ASCII value 31. Then in the accumulator we will subtract from 30. So 31 is also hexadecimal, 30 is also hexadecimal. So 31 minus 30 is 1. So you write it in terms of 8 bits here. So 1 is written as 0000, then 0000. Okay, and then we will see in the register also. See, after this it is not having any value which is less than, which is more than 10. So what is happening is we will just return it to the accumulator here. So save in register is, so in register also we will be saving the same bits here. Okay, now after saving bits here in register, we are doing shift L operator for with 4 bits of byte. Okay, so how are we doing it? So these are gone, these 4 are out. Okay, these 4 bits are out now, and now this 0 has come here. Okay, I'll just clear it and do it. So this 0 has come here, This 0 is shifted left, again 0, again 1. Now these left outs are filled with zeros. So now after doing shift L operator, okay, now what do we have in the register is we have 0001, then 0000. Okay, fine. Now after this, let us take, now see, look at this one. Once we are shifting it, okay, shift L S4, see, shift L S4, we are again moving to the subroutine get C. Okay, that means why are we moving it to get C? Because we need one character we have read, and we need to read one more, the second character 7, so that when you combine, totally 17 should occupy 1 byte of memory. So every time in the function, in the program, 2 bits are read and then will be converted into 1 byte. Is that clear? Okay, now we are here. Now again I'm reading the second character C, that is 7 here. Okay, so again we will go back here. The same procedure continues here. So 7 equivalent is 37 in ASCII. So again subtract from 30, we will get 7. So you write it in binary. So 0000, then 0111. Now put it in the register. So what do we have in the register? Register we had, register S we had 0001, and then we had 0000. So 0001 is there, and then this is already there, and then 0111 will be added here. Okay, so this is your register S. Again, we, even if I shift it, I mean, like, I don't need it. Okay, I just need the value in the register S. So look at this one now. What is 00011? What is 01117? So 17. Look at this. This 17, which was occupying, which were occupying 2 bytes of memory, in 1 byte itself they are fit. Okay, so 17 taking 2 bytes of memory, now 17 taking just 1 byte of memory. That means each character, each digit in hexadecimal, that is each digit of the object code occupying half byte of memory. Okay, so the same way we will do even with the next 2 digits. Okay, so 2, it will be taken as 0010 after shifting. Then again 30 minus 30 is 0. So 0010, and then 0000. So we get 2 0. So this is how it will. Okay, now let's come to the next one. The next one is having a digit, is having a character D now. Okay, so 2 is taken as 32, D is taken as 44. Okay, that they are the hexadecimal equivalents of ASCII. Now 32 minus 32, since it is less than 10, we will just move it to the register S. So 00000010, we will shift it to the left. So I get 00100000. Okay, now let's come to D, 44. So what is 44 minus 30? That is 14. Okay, 44 minus 30, they're all hexadecimal numbers, guys. So 44 minus 30 is 14, which is hexadecimal. Now look at this. If the result is less than 10, then conversion is complete. Otherwise, we need to subtract 7 more. Okay, now D is greater than 10, correct? So we need to, sorry, this one, 14, I'm sorry. 14 is greater than 10. It is not less than 10. That is why we need to subtract 7 more. So 14 minus 7, hexadecimal. So it is not 7, okay? 14 minus 7 is D. Okay, so the accumulator will have D, that is 0D, D, 0D, that is 0000. D in terms of binary, it will be 1101. Okay, fine. So now you have to store it in the register S. So 0010 I have shifted here. Now 1101 I have added here. I have combined. You know, I have joined them. So 0010 1101 will be the register S value. So what is this value? 2D. See, look at this 2D. Instead of taking 2 bytes, they are taking just 1 byte of memory. So this is what we call it as Bootstrap loader, and it is also a very important topic from the exam point of view. So you can take one example like this and then explain the code, program and the algorithm. Okay.